Welcome to this series of videos all about map reading. First off, we're going to look at what a map is and how we look at a map. So in front of me I've got a map from the Black Mountains. The map is broken up into different things. The idea of a map is it represents the ground from an above the air kind of scale. So you're looking down over the map. And instead of having, say, a 3D image, we've got things that represent different parts on the map. With all maps, there should be your information regarding what that map contains. So this map is taken from an Ordnance Survey map, and the Ordnance Survey map will have all of the key features and map symbols represented that are shown within the map or in the local area. Maps also hold information regarding the different print dates, which are important when we look at magnetic variation, and also the grid reference that represents the map as a whole. So if we look at the grid reference first, the country of the United Kingdom is split up into several different larger map squares. Each map square that you see that starts in the corner and is the size of the entire map is around 40 kilometers square. So you normally get 40 kilometers on a single map. Every 100 kilometers on the map is represented with a different letter system. So the corner of this map shows that the letter is SO. This is relevant if you're looking to show where you are within the UK, but for day-to-day purposes isn't going to be needed. What's more important is how that 100 kilometers is split up, and this is by your grid references that move along and up. As we go along, you'll see that there's a vertical line that goes straight up, pointing towards the representation of north on the map. Every one is 1 kilometer to the east. So each line that goes straight up is referred to as an easting. That's because they are one additional to the east, one additional to the east, one additional to the east. We also split the map into northings, and these go one to the north, one to the north, one to the north. Northings go horizontally along the map, while eastings go vertically up the map. Within the map there are lots of representations of the ground. For example, areas of green show woods, areas of kind of a brown colour show open access land, and we've got roads, rivers, towns, as well as contour lines that represent how steep the ground might be. We also have rock features, which might be cliffs or crags. We also have individual map symbols, like the parking symbol, the symbol for a pub, or a campsite. These symbols are always shown along the side of a map so that you can reference between one and the other. In short, a map represents the ground that you see from above, and it uses different symbols to show you what that looks like. Instead of being a 3D image, we have contour lines and different symbols to represent different parts of the map that you might see on the ground. So that's an overview of maps. We look at the symbols to see what they represent, and each map is split into different 1 kilometer squares so that we can show and tell people where we are on that map. So this video is going to look at the parts of a compass. We've just looked at the parts of a map, and a compass is one of the instruments that we're going to use to help us to navigate. There's lots of parts to the compass, and we'll go through all of those parts before looking at what they do and also which parts are going to be most useful for you. So starting from the middle and moving outwards, we have the compass housing, which houses the part that spins around and points to the north. That compass housing has the ability to twist, the twisting part, is known as the bezel, and it allows us to align the compass to whichever direction that we wish. Inside the compass there is a needle that points north and south, and within the bezel there are lines known as orientation lines that go up towards whichever direction is currently showing as north. You can see here that on this demonstration the needle is pointing to the north, and I've aligned the compass so that the N is at the top. This window in the top with this line is known as the index line, and that index line is used to put specific degrees of angle so that we can follow these whilst on the map. Outside of the compass is the base plate itself. Along one side you'll often have a ruler. You may have a ruler in a different scale on the other side. At the rear you have your lanyard. This is normally used to tie the compass to you, or otherwise to keep the compass safe. You normally have a magnifier, a target window which can be used to draw or to show areas on a map. And on silver compasses, like this Silver Exped 4, you also have a roamer, which is in several different scales. The corner of the compass is straight, which allows us to take bearings. And underneath the compass, in 3 spots, are little sticky pads to ensure that the compass doesn't move when we move it and stick it to the map, so it should be gripping. The index line that we have shown here goes in line with what we call the direction of travel arrow, and that in turn may have an additional direction of travel arrow as seen here. This compass has several glow-in-the-dark features to make it easier to use at night. One in the north, one between the index line, and one along the direction of travel arrow. When we use our compass, it's important to set our compass either so that it always points to the north and orientate our map, or use the different bearings within the bezel to set different degrees. On this compass there are 360 degrees. Some compasses, known as Mills compasses, have 1 militaire, which is 6400 within a circle. And we'll talk about that at a later video. The compass itself can be used to help to travel along a certain direction or to orientate your map to the north. Important parts to think of: the needle, the bezel, direction of travel arrow, and the roamers. All of these will be used whilst navigating. So that's the compass. This is the front, this is the rear, and this is the actual compass part itself. So this video we're going to look at how we use the map and compass together to give us an idea of what we're looking at on the ground. So I've got both my map and my compass, and the skill we're going to look at is orientating the map to north in reality. So if we look at the compass, we can see that the north arrow is currently pointing over in this direction. That arrow with inside is the true north, and to help us to orientate the map, we're going to twist the bezel so that the orientation lines are to the north. As I place the map and the compass together, what we want to see is that the compass allows the map to point to the north along the eastings. To do this, I let the map rotate underneath the compass until the needle points along one of these eastings. An easy way to do this is to place the needle on that and orientate it to the north. If I do this whilst out on the ground, what will be shown in front of me on the map is what I'll be looking at along the direction that I'm travelling in. So if I'm travelling in this direction, what's represented on the map in front should be what I see. In this map of the Brecon Beacons, for example, if I'm now standing along this river, in front of me I should see, to my quarter left, a large hill which plateaus across and seems to fill a large area. If I look to my half right, I should see a town or village, and then in the distance behind that I should see some more hills represented on the map here. So reviewing that skill again, to orientate the map, what we need to do is we need to find the north on the compass. We then place the compass onto the map and twist the map underneath the compass so that the north arrow points towards the north on the map. It's important that both the arrow of the north and the needle point to the same direction. You could choose to make it all aligned to the north, or you can simply point the north, which is along one of these eastings, along the needle point with the north on the map. So for this video I've taken us to the computer just to have a closer look at how a map is split up. What we have in front of us here is a representation of a square kilometre in the Surrey Hills area. The square kilometre is split along these lines, which are our northings, which go one to the north and one to the north. They go horizontally, and our eastings, one to the east and one to the east. On a larger map, this would be seen as a small 4 centimetre square. We've blown this up for simplicity. When we want to tell someone where we are on a map, we need to use the grid reference to tell them where they are. When we use a grid reference, we always represent the left hand and bottom numbers that are shown on the map. So in this case, the left hand number is 10 and the bottom number is 50. That means that on the 100 kilometre squares that we have in our whole map system, we are in the 1 kilometre square that is represented by 1050. This is really useful, but it doesn't give us a more accurate space within this 1 kilometre. You could, for example, be at one of these buildings, you could be next to this pond, or you could be in the centre of the woodland. And if we need to know where you are, or you need to tell someone where you are, you're going to need to think about splitting this into a smaller representation. So the next thing that we'll do is a 6-figure grid reference. We've got the same area that's been zoomed in on, and I've overlaid a grid that gives us a representation across the bottom. So each of the grid squares is represented with a smaller square that is seen as this 1050 and then in the corner. So for example, this corner is known as 100500. What we want to do is we want to tell people where we are. If I want to tell someone that I'm at this small building, what I can do is I can read along the corridor, knowing that my first number is the big number represented on the map, 10, and then I go along to see where it sits into the next box, 4. So my first number is 104, and then I'm going to read up. I'm starting on 50, and it is in box 4. So I want to show that I'm in this area here. I'll read off 104, 504. I could do this for any part of the map that I'm in. For example, if I want to show that I'm in the top corner of this map at this building, I'd be using 108 and then be reading off 509. So that's taking a 6-figure grid reference, and it allows us to tell someone where we are within 100 meters. We can do this on the full map by guessing where each of these numbers would be represented and splitting the box in our heads into a further 10. So when I do this without the overlay, it looks like this building that we looked at to begin with is around 10, and it's not quite halfway, so I'd say 4. And then I look up the side, 50, and it's just a little less than halfway, so I'm thinking 504. The next video will look at how we use a Roma to more accurately convey this and measure this with the compass as well. So the last video looked at grid references in general and how those are split up. This video is going to look at how we use the compass, and specifically the Roma of the compass, to take an accurate 6-figure grid reference. This is really useful when telling people where you are, because it will give those people an idea of where you are within 100 meters of your true location. To begin with, we're going to think about where we want to say we are. So if we've identified that we're at the top of this reservoir, there's actually a nice little shelter here, then I'm going to need to work out, to begin with, my 4-figure grid reference. So I know that I'm in grid square 2231. We always go along the corridor and then up the stairs as a rhyme to remind us which box we're in. This is great because it will tell people that we're in this square kilometre, so this 1,000 metres. But I want to say to someone that I'm specifically at the top of this reservoir. We looked last time at splitting these grid squares into 10, both along the corridor and up the stairs. What's very useful is that the compass does this for us. So as I lie the compass with the corner, most part, pointing where I want to represent I am, the corner being this black line where it conjoins, I make sure I'm using the 1 to 25 scale Roma, because this is a 1 to 25 scale map. When I lay this over with the corner pointing in, I can read along the corridor, which gives me 22, and then as I go up towards the top of the Roma, wherever this line intersects, I can read off the number. So I'm at 226 for along and up 312. So the two numbers I'm looking for are 226 and 312. I can do this with any position on the map as long as I put the corner in. For example, birdhouse shown here. I put the corner of the Roma where the birdhouse is. I then move along the corridor, 226 again, and then up the stairs, 328. This is the quickest and most reliable way to give a 6-figure grid reference. If I want to be more accurate, I can use the small delineation, as you can see here, for 50 meters instead of 100 meters. The marked delineation shows every 200 meters. So we have 200, 400, 600, 800 and 1000. Same with the vertical. We have 200, 400, 600, 800 and 1000, along with the small 50, 100, 150, 200s. So that's how to take a 6-figure grid reference using the Roma on the compass.